Hi, and welcome to this video on lesson design for science at the secondary level. I want to talk about a few different things, really two main ones. One is the role of the 5E lesson cycle and guided questions for a 5E lesson, and then also how to write good quality objectives. So let's take a look here. So what are the parts of every good lesson? So if we want to hit a lesson right on target, how do we incorporate the process of science? So do we work from curriculum to instruction to assessment to standard, or do we think of our standard and our course objective first and then go through and figure out how to build our lesson? Well, we want to start with a backward lesson design. So we want to figure out what is it that we want students to accomplish and be able to demonstrate in the end that will allow them to prove that they have met a certain standard. And if we're going to know that they met that standard, then we're going to have to assess them on that. But we have to clearly understand exactly what it is that we want them to accomplish so we can design a great assessment for that. As we work towards that assessment, we want to provide instructional opportunities for them to gain or learn the content and the knowledge in which they'll need to learn. And then that really dictates, what our curriculum is. It's not just getting a packaged curriculum and then following that curriculum along. It's really being a teacher who can identify what do we want students to learn, how will we know they've learned it, what will we do if when we assess them they have not learned it, so how will we differentiate, what will we do with some students that when we assess them they have learned it, and so how will we enhance or enrich their learning and help them go beyond. So let's talk about 5E lesson cycle. So we have different components to the 5E lesson. There is engage, explore, expand, explain, and evaluate. And so as you look at these, you notice that there's constant arrows in between all of them, because during a lesson we should be moving from various parts of this 5E cycle. So let's talk a little bit about how we use the 5Es in class. Let's start with engage. So we can engage students through demonstration, describe an event by questions or questioning, and by challenging them. How can we have them performing in activities where they're explaining? So we could have them in small groups. We could have a whole class discussion. We could have them developing concept maps. We could have them creating a model or defending a model. We could have them answering a journal prompt. Okay, so that would be a way to get writing into it. How do we get them to explore? Well, we can have them doing experiments. So these could be experiments that we design for them or experiments that we ask them to develop. We could have them doing some inquiry exploration. We could have them doing some engineering design. So maybe they are tasked with a problem and they need to design a prototype or something that will solve that problem. We could ask them to collect some data. We could ask them to make observations. How would we have them expand? Well, we could have them ask new questions about what they learned. So I noticed, I wonder, I want to learn more types of things. So what is it that you want to learn more about? And then how could you go about learning that on your own? Extended examples. So we could have multiple examples of various topics and concepts. We could have new investigations. We could plan field trips, whether they're virtual or real field trips. How are we going to evaluate performance? Well, we could have a traditional formative or summative assessment. We could have a performance assessment. So it's really about, what is the purpose of your evaluation? Why are you having that evaluation or that assessment at this time? And then going from there. So as we take a look at some different benchmarks, these are how our standards are written. So if we look at this human effects on ecosystems, benchmark 94412 says, describe the social, economic, and ecological risks and benefits of changing a natural ecosystem as a result of human activity. So our action verb there is describe. Think about how you might have students do that. What conditions might you require of them, or what criteria might you require of them, or what performance would you have them do to describe that? And so that brings me to objective writing. So from your text, page 47, it states clearly worded instructional objectives have three characteristics. So there's going to be a performance component, which specifies an observable behavior that the learner is to exhibit. It's going to have a conditional component, which specifies the conditions under which the learner will be assessed and what the learner will be given or denied. And it's going to have a criterion component, which specifies the minimal level of acceptable performance that the learner will be expecting to exhibit. So let's just take a look at some examples, and I think it'll start to make a lot more sense. So these examples have all three components in them. So the condition component is in italics, the performance component is in bold, and the criterion component is underlined. Given the diagram of the heart, that's my condition. I'm going to give the students a diagram of the heart. Identify the structures of the heart. So what am I going to ask them to do? I'm going to ask them to identify the structures of the heart. And what criterion am I going to ask them to do? They need to include the chambers, vessels, and valves of the heart. So I have my condition, my performance, my criterion. Let's look at the next one. When given the structural formula for an unknown compound, so what condition are the students going to be given? They're going to get a structural formula for an unknown compound. Distinguish the compound from others. So what performance are they going to do? They're going to distinguish the compound from others. How are they going to do that? By naming the compound and its functional group. So they're going to talk about the compound and its functional group. Let's look at some others. So again, remember the condition is in italics, the performance is in bold, and the criterion component is underlined. With black construction paper, white construction paper, aluminum foil, and glass, so that's my condition, that's what the students are given, judge how well different materials stop radiant energy, that's the performance, by presenting a bar graph of the data collected in this problem. So they're going to have to present a bar graph. Okay, and so that's the criterion. Let's look at this last one here. With the aid of the periodic table of elements, so what's the condition? They're going to have the periodic table. Classify the elements. That's what they're going to be asked to perform. And we're going to ask them to classify them into groups 1A through 8A. So what's the criterion that they're going to have to do? They're going to have to label them groups 1A to 8A on the periodic table. When you design your lesson, you want to think about engage, explain, evaluate, explore, and expand. How are you going to incorporate those throughout your lesson?